next topic.
Sandeep will introduce us first. So any chance we can have all three mics on, or is it? Yeah.
So stand on this side.
Gravitate on that side.
Over here.
Got it. Come around.
Okay, we're going to continue to stay a little bit ahead of schedule today. And what I'd like to do is introduce our next speakers. They're going to be talking a little bit more about Dent with SAI. That was a great introduction with Vlad and Andre about, is Dent going to be, running SAI? So this was a great segue for that. So I'm going to let each of you introduce yourselves as you speak. And we're actually going to extend this because we have 3 speakers from 25 minutes to 30 minutes. And again, we are running ahead of schedule a little bit. And we'll save some time for questions at the end. So thank you very much. Gentlemen.
Cool. Hello, everyone. Welcome. Thanks for joining us for this presentation. My name is Sandeep. I'm a principal engineer at Amazon Web Services, primarily focusing on embedded devices and operating systems. We have here with us Larry, who is the chairman at Edgecore Networks and VP of Engineering. And we also have Constantin, who is software architect at Luxoft. So in today's presentation, we're going to be giving an overview of Linux enterprise or edge networking solution called Dent from a community and from technical perspective. And then we're also going to be discussing on why and how we are adopting OCP switch abstraction interface or SAI into the Dent solution, right? Larry, do you want to give us an overview of the Dent ecosystem and its components?
Certainly. Hello, everyone. So in the next few minutes, I'm going to share some of the background of Dent. I assume many of the audience are very familiar with Sonic. It's been front and center of the workshop yesterday and many of the presentations, even in this track. So Dent started as a Linux Foundation project. Actually, this was before Sonic moved into Linux Foundation. So Dent started in 2020, and Edgecore Networks was one of the founding member of Dent at the time. And it was formed as with a set of missions in mind. It is, first and foremost, is a network operating systems that is targeted for edge, retail stores type of enterprise edge use cases. And at the time, Sonic was still very much concentrated on data center. So, and over the first, since 2020 into 2021, for those of you who follow Sonic closely in the community, you see that there were starting to have proposals to start adding features into Sonic that perhaps are not classically deployed for data center use cases. Things like spanning tree. And so it was met with quite a bit of resistance by the Sonic community for right or wrong answers. It's not my purpose here to debate that. My purpose here to only point out that Dent was formed in 2020 specifically with enterprise edge use cases in mind. And therefore the Dent OS, which is more of now people just commonly refer it as Dent. Dent is actually the common term, the collective term of an ecosystem that was formed at the time with Dent OS being part of the element, a key element. I'm going to talk a little bit about that later on. And so the mission was actually quite simple. It is open source. It is community driven. And Dent, when it was founded, tried to learn from some of the success factors because by 2020, Sonic was already quite popular. It continued to get more popular day by day. So when we look back at what makes Sonic successful, at least as far as drawing attentions and getting all the hypes, and some people still today classify that as hypes, but that's another story. In Dent, in 2020, when it was formed, it was looking back at Sonic, we immediately recognized you need a broad ecosystem participations from vendors, from end users. Vendors, not just a particular level, not just software. It is a software, but you need participation of the ASIC vendors. You need participation of the switching vendors to form the complete ecosystem, including testing vendors. And so that was first and foremost our mission. And then, of course, being an open source, you need to pump up the community. You need to draw participations from also the users, the developers. This is first and foremost a very important mission in our mind, and therefore it leads to then forming things like test subgroup, looking at drawing in the testers and trying to people with test in mind and more focus from day one about it. And then, of course, the end user, the operators, those are all very important. How do we draw them in? And as we rolled into execution, these are all factors to be considered. And finally, being open source, it must be neutral. So this is fundamentally the charter of Linux Foundation. Every project that is an LF or LFN must confine to it. So therefore, it's built in as part of our mission. So that's the mission, all right? So how do we execute towards that? And I was reminded when I first started my career, one of my mentors in the industry, he told me, I can never forget that. He said, a vision without execution is hallucination. So Dent, over the last several years, focused heavily on executions to realize our missions, our visions. And so this particular slide talks about the different elements, the different components on executions that we have to take care of. Starting with Linux, Dent being a Linux-based OS, Dent first adopted switchdef. And for those of you who are not familiar with it, we're adopting the ASIC abstractions via switchdef switchdef is a Linux kernel drivers. And so, and again, there are pros and cons on every technology approaches. So we had adopted switchdef for the first several years, absorbing the results, looking at our mission across, and now Dent, the community, has decided to also expand the adoption to include SAI, which is really the reason why we are talking today. And so, again, Constantin will talk more about the SAI, specifically how Dent will adopt SAI in the following slides. But the other, let me quickly go over the other silicon components. Silicon, we got Marvell, that's one of the founding members. Now, by adopting SAI, we are very hopeful that other silicon vendors who already have a SAI library for Sonic, it's a no-brainer for them to join in that case. Yes, you still need to implement the SAI support, the specification. The OCP SAI community still needs to expand its API to support the enterprise edge specific APIs. But those are the challenges and perhaps on our call to actions. And then our hardware vendors, right? You can see here, besides Edgecore, Delta, and also Wistron are members that today have hardware switches that are supported and running on Dent. And then, of course, software. Software is, and I'm very proud to announce, by the way, we have just, Dent community have just rolled out version 3. This was just announced yesterday, I think. Depends on which part of the continent you are in. It is there now. It has added very important features like IPv6. It's adding IGMP, I believe. It's also there. Some of the features these are specifics to like IGMP is specifics to enterprise edge, but features like 802.1x, security, authentication, that is commonly across on every networking OS component needs to have it. So besides the control plane features, it is also important to have telemetry and configuration and provisioning in mind. This is perhaps a #1 challenge. I think that's debatable too, but it's one of the key challenges of adopting an open source NOS technology. It's how do customer would say, I'm interested in it, but how do I handle my day zero? How do I handle migration and all that? And so this will be a challenge for Dent too, not just for Sonic, but also for Dent coming up. So we're looking at putting in the foundation, the pipelines inside the Dent OS to enable more telemetry, to enable maybe other applications, vendors, third parties that's coming in and join this community and trying to provide solutions for day zero. Last but not least, I want to talk a little bit about the support. To us, there are two sides of the support. There's the developers. You want developers to join the community, to start participating and contributing code to it. The most important part is to have an infrastructure that allow them to test and submit a code. You do not want to hold them up with a long push request or submission process and approval process. Code must be tested, verified quickly. And more importantly, ideally, the code should be able to verified and validated on real hardware. I know VM is convenient, but there's constraints about it, right? You cannot test the actual data plane and the packet forwarding and all that part of it without the real hardware. So Dent built this into our test subgroup starting from day one with the participation and leadership of Keysight. It is addressing this problem with real testbed, real hardware testbed, and looking at it and trying to address some of these issues. And so that's one part of it, taking care of the CI/CD and also the developer contributions. Then there's the end users. Amazon is doing a great job of facilitating and help to push Dent forward. We need more operators to participate. And so one of the concepts that's being built inside Dent right now is along the line of the OCP Experience Center. We want to be able to put together Dent OS on Dent-enabled hardware in an experience center where the operators or customers that actually are retail store owners and all these other companies that are looking and curious about Dent to be able to experience, be able to come in and try it out and experience through it. This is the concept of taking care of the end users and support them from even before day zero, day -1, and let them have this concept. And this is something that we're doing. Every one of these components is done not by one company, but by many of the companies that are currently members of Dent. And we hope to also continue to attract more companies continue to join this growing community. Okay.
Thank you, Larry, for that holistic overview. And I agree with you. It's really when the entire ecosystem comes together that we make progress, and we should do everything to keep that flywheel moving without, hallucinating, to your point. So now let's move on to the technical overview and existing architecture discussions before we start discussing why SAI, right? So Constantin, do you want to give an overview on the technical specifics and feature offerings in Dent today?
Sure, absolutely. So Dent OS aims to be a new standardized network operating system with no overhead and no abstraction. And so basically, it's Linux native implementation. And how it aims to do that, it aims to leverage all the existing control plane tools that Linux has and be able to use them without having to change them. So this starts with things very simple, like IP root tool, to ways to enable an interface or add a route, manipulate the routing table, ARP entries, and so on, but goes all the way to using all the Linux-based daemons, using more sophisticated suites such as FRR to have dynamic routing protocols and so on. So the key goal is to use all these control plane tools just the way they were developed without needing to adapt them to a different abstraction. So the way this is done in DentOS is by using switchdev. Switchdev is an in-kernel Linux driver model. So this is available actually in the mainstream kernel source. And it's a way of providing NetDev, network device Linux drivers that just behave similar to anything you're familiar, like the ETH0 on your laptop or just the regular network interface card on a server. But at the same time, behind the scenes, it's able to offload all the functionality that the hardware ASIC can do for you. So basically, it's able to offload Mac learning, switching, routing functionality, a lot of powerful things just happen behind the scenes, and you just control that via the usual Linux tools. So you want to create a bridging instance, you just use the bridge user space tool, you aggregate, and you want to create a link aggregation group. The same, you just use the standard tools, aggregate ports into a lag. It just happens behind the scenes that it works with the ASIC that you have underneath. Also, to add to what DentOS brings, so it has vendor-specific drivers. Also tying back to its own roots, it has things like ONLP to be able to interface with things such as PSUs, SFPs, thermal, LEDs, and so on. And then it brings a number of qualities that you can see there on a number of benefits that you can see there on the slide. So the automated tested suites and all the community support, no software licensing, and so on. And on top of that, being Linux, it's open source, so you can have access to source code, or you can have access to binaries that can just simply work on the hardware. So we can also take a look at the feature set that DentOS supports, and maybe I'll just start with those that aimed at the enterprise. So it has everything you need for bridging .1Q VLANs. It has link aggregation groups. It has layer 2 and layer 3 ECMP. It has things like policing the control plane traffic, data plane traffic, VOM traffic, and so on. It has very strong ACL filtering by leveraging TC Flower. It has all the powerful routing before forwarding a function, so you can do static routing, you can do dynamic routing, as I was saying before, by leveraging, for example, FRR. So, and you get OSPF, ISIS, BGP, and so on. It does VRRP, virtual redundancy routing protocols, spanning tree that Larry mentioned, which is an important addition. So basically, root prevention via MSTP, RSTP, and so on. So maybe just
so maybe we can dive deep a little bit more. Like, we understand that Dent is a lightweight operating system, and in terms of hardware resources, etc. But can we dive deep a little to see if how Dent differentiates itself from the other open source offerings in terms of feature set?
Yeah, absolutely. So there's a number of features that you can highlight in that category, right? If you look at net is not so easily available, right? With especially with this model of all-loading to ASIC functionality and line rate forwarding and so on. Also things such as PoE, security features. So I'd highlight secure boot, TPM, 802.1x for sure. So these are I think important differentiators in the feature set that DentOS brings.
Yeah, thanks, Constantin, for that overview. Yeah, like you rightly said, Dent is built on Linux, and we use the TCP/IP stack, control plane implementation of networking protocols, and the switch dev infrastructure to write in-kernel switching drivers. All of these are natively available in Linux, and for a typical edge and enterprise use case, for the most of the feature set that you need is already available in Linux, right? So this is the core benefit that Dent brings in its solution. And over the last couple of years, to Larry's point, we've already done 3 software releases in the operating system. We've onboarded open source hardware specifications for silicons from various vendors like Marvell and Mellanox, et cetera. But one important thing we realized through this journey is in-kernel driver development comes with its own development overhead, right? We need to acknowledge that. And in terms of cost, in terms of project timeline, et cetera. And after acknowledging that, we kept thinking as to for ways in which we can accelerate adoption of Dent solution and speed up software development without really compromising on 4 key things. The first one is we don't want to let go of any of the benefits that native Linux offers, right? We don't want to make architecture changes that would sort of negate that. And then the second one is we don't want to close doors on in-kernel development. It's a philosophical debate in the technical community, and we don't want to close that door, right, through this architecture change. And the third one is any software development we want to do for the future needs to have the same benefit. We shouldn't come around like 2 years from now, start thinking what is the next architecture of change we need to make, right? And the fourth thing is we want to find a good home for this open source collaboration, and OCP seems to be the right place for that. So with all this in mind, Dent community and Amazon puts its weight behind and comes with the commitment to extend and enhance SAI offerings and make it capable for onboarding to solutions like Dent and any other equivalent enterprise and edge networking. And also enabling SAI in Dent enables the operating system for OCP-approved hardware platforms like Edgecore's AS4630 and AS7326, right? So diving deep a little more on the architecture changes to onboard SAI in Dent, as you can see, we've made some very specific one-time infrastructure change in Linux kernel to extend switch dev drivers to be able to make SAI API calls in the user space. Essentially, this minimalist change and adding that shim layer allows us to meet the 4 tenets that I mentioned earlier. It allows us to continue to take advantage of in-kernel driver development or user space driver development for the future. It allows us to take advantage of all the native offerings that Linux has, but also does not impact adversely the scale and performance of the solution itself, right? We have to be very mindful of that. Dent is lightweight, it's fast, and it needs to continue on that path. So we've been consulting with various members in the open source community, in silicon vendors. We worked through multiple people, and we've aligned on this architecture and started on development. And essentially, Constantin will explain a little more on the specifics of changes that we've made in hardware architecture here.
Sure. So what we think needs to be done in this case is basically to have the in-kernel driver just be one generic driver to be able to handle multiple ASIC models from multiple vendors and so on. And the way we think this can be done is by still leveraging switch dev. So the approach and the philosophy remains the same. It's just that underneath, instead of looking for a directly connected hardware ASIC like on the PCI bus and so on, we just use netlink to communicate to the actual driver of the ASIC. So you can almost view this as a netlink bus where the ASIC lies. This is where you detect the ASIC, and this is where you program the ASIC and so on. And over this netlink communication, we can get on the other end a switch manager, which is a very lightweight shim layer. It's just a user space app dynamically linked with libSci. So depending on which ASIC you have, you link to the appropriate libSci implementation. But from the switch manager's perspective, this is, again, generic, right? So there's a common way of interacting with various ASICs. So this shim layer, what it does is just it translates from the language of the kernel driver, which sends generic netlink messages, and then it translates to the SAI APIs that need to be called to program the hardware. So as an example, for if the hardware ASIC will learn a MAC address, it will notify via the vendor SDK and via the SAI interface. It will be a common SAI callback with a MAC learned. But then this switch manager will translate this to a netlink message to the generic kernel driver, which is able to then act on it just like any netdev driver in the kernel. On the opposite direction, if you want to create a VLAN or if you want to program an ARP and so on the interface, it's just a netlink message to the switch manager, which translates this to a SAI API call, which does the appropriate programming in the hardware. I think this about describes it.
Thanks, Constantin, for
Yeah,
that.
sure.
Yeah, this architecture, some of these architecture changes may look familiar in the market. People have done this before. It's a slight variation of that, essentially. Yeah. So now, call to action. So essentially, we understand that there are numerous enterprise and edge networking owners who are looking for open source solutions to adopt in their environment, right? And that is where we call for people to collaborate with us in OCP to extend SAI, to enhance it. SAI already has a wide range of attributes to support all of these feature sets, but it may not have been tested enough or adopted enough or deployed enough. That's where the devil's in the details, right? So we want to collaborate there, enhance where needed, extend where needed, and be able to adopt it in solutions like Dent and other enterprise network operating systems. So we're going to be, Amazon and other members of Dent community are going to be participating in OCP SAI working group as part of enterprise connectivity solutions. And we will, like I said earlier, we're committed to putting our weight behind this extension. Also, I'd like to invite you guys to visit the Dent website and try out the solutions, give it a test drive. All the hardware offerings, all the software offerings are in there. We also have the technical steering committee and testing working group and the customer advisory group and multiple other groups that you can participate. All the schedules and timelines are available on the website for the help that you need or consultation, et cetera. We also have various hardware ODMs who are doing those hardware offerings. They're also part of those working groups. So you don't have to sort of look for help. So it's all in one-stop shop. And finally, the important thing, I want to tie all of this back to the 48-port multi-gig PoE switch for Edge Gateway that was announced by Amazon and OCP yesterday in Keynote. The development of that hardware itself has started. We are working with multiple ODMs and silicon vendors like Marvell, Broadcom, Mellanox, and Edgecore, Acton, Rigel, and other ODMs essentially to, it's already wheels in motion, and we expect that to be GA in first half of 2024, right? And the implementation of all the changes to adopt SAI in Dent also is expected to complete end of the year, Q1 of next year max, and those two align really well, right? And the solution that we implement in SAI and Dent will also onboard and support this multi-gig edge gateways hardware specification. So it really works well. So for all the customers, enterprise customers, and everybody to come work with us in developing SAI and this hardware product, essentially provide feedback, contribute through code, testing, and as a customer, et cetera. And that would be really nice. I mean, Amazon is really looking forward to collaborating in OCP and contributing to it. So, yeah.
Well, thanks. We have a few minutes, so what I'd like to do is take a little time to ask some questions. I have one, but I'm going to let the audience go first. Any questions for any of these folks? Yep, there's a microphone there.
Yeah. Thank you so much for the introduction here. So given that ONL itself might not be the most actively maintained project, and Dent is heavily relying on that part for building itself, how do you see the future of Dent in terms of replacing ONL, picking up ONL again, maintaining it? What is the idea there?
So that's a very good question. And we actually, Michael and I wanted to sort of have that as a separate specific talk, but there are too many talks in this regional conference, so we had to sort of compromise and let's stick for this. So the answer to that is we've tried a few things. Actually, in last year's global summit or the year before, we actually tried to take over ONL working group and try to make it push forward, but it didn't work, right? The community wasn't putting its weight behind it. So right now what we're doing is we are moving over from bits and pieces from ONL to Yocto for build itself. We're working with multiple people in the open source community to make that happen. For now, we're going to stick with ONLP platform drivers because we don't really see any big gap there. The build system is where we see the gap. Platform drivers do their job. We can extend or write new drivers in kernel or in user space and use SAI for now, right? We're fine with that. But to answer your question, yes, we are already addressing that and moving away from it.
Okay, thank you.
So in Sonic, there's a Redis database that kind of handles, that's the single source of truth for the state and the switch. How do you plan on resolving discrepancies in state between what's going on in the actual switch and like kind of behind the scenes with SAI versus what's going on in the Linux kernel, which probably has its other ideas of what's going on?
Yeah, so that was one of the key challenges, and that's why we consulted with multiple people on the architecture. So essentially, the consensus is that we need to stick with kernel as a true source of truth, right? For two reasons. One of the tenet I mentioned was we need to keep Dent lightweight and in its footprint. We don't want to change that. That's the benefit. That's what it differentiates Dent, and if we change that, then we're losing track. So yeah, we're going to keep kernel as source of truth, and the shim layer is supposed to have whistles and bells in it to make sure that things don't go out of sync, and we're going to have limited resource management and database management in there for features that absolutely need sort of maintenance. We're not going to lie to us and say it's going to be a very thin layer without bulkiness in it. But at the same time, one of the tenets will remain that we're not going to replicate the Redis DB or such a heavy database for just the enterprise and feature set that are essentially needed for enterprise and edge retail. Yeah.
Thanks, good answer.
Michael, you had a question? Oh, sorry, okay.
Yeah. Yes, I also have a question related to probably to Sonic. SAI interface is generic, but in fact the implementation can be vendor specific in sense of dependencies. And as you know, in Sonic this is addressed through the Docker containers. But also another question, there can be a kernel driver that is needed by SDK. Let's say when you create host interface through the SAI. So two questions, dependency, how you are going to address this, and in case of host interface creation, usually vendor-specific code create these host interfaces in Linux, I mean network devices. In case of Dent, who will be responsible for that?
So yeah, Constantin and I were talking about, Taras and I were talking about yesterday on how we cannot probably ever get away with some vendor specificity in implementation. It could be like IP, like intellectual property dependency, or the fact that the pipeline and the ASIC itself is designed in very differently, right? So yes, there will be some, for example, like control plane punting path I think to your question, yes, there will be vendor specificity. We will continue to have kernel drivers for that, for CPU tap interface and etc. The silicon vendors have been gracious, like both Marvell, Broadcom, and others that we've spoken to have been open to providing that solution in kernel for us and working with the community to make that happen. So that's our essentially answer to that. Constantin, do you want to take the dependency question for?
Yeah, sure. But
Yes.
I think in general what you said, I think kind of addressed it. So basically the idea is that we'll try to keep the common path in the user space piece as much as possible. But wherever there needs to be something that is specific to a vendor, there's probably going to be small contained areas where, and hopefully temporary, that will be there and there will be vendor specific. And then the aim, I guess, is for the whole community to bring everything back to a standardized API. So I think the goal, all of us, what we want is for SAI to offer everything that's needed and to be completely functional across all ASIC vendors. So hopefully that's where we'll get at some point.
Thank you.
Sure.
Okay, thanks. Taurus, if it's really quick.
Yeah, quick one. The application that will work on top. Yeah, the application that will work on top of SAI. Are you going to open source this as a part of DentOS, or this will be the vendor specific?
Absolutely, yeah. We will absolutely. The alternative is to open source it. The timeline may be a little bit off between software releases and open sourcing the drivers that we write and what we get from vendors. But the tenet is absolutely to open source it and make it available for download and installation and up and running. Yeah.
So
Essentially, the goal is for system integrators. The gap today in Dent, like indirect message we're trying to say, is system integrators struggle the way it is today, and we should not implement an architecture change and keep that problem in place.
So if I have the box that runs Sonic, technically, I could
Exactly.
run Dan on that.
Exactly. Yep.
Okay. Well, thanks everyone for joining. And I want to thank our speakers, Constantin, Larry, and Sandeep. If we can give them a